Good day, everyone. And continuing our topic on sets, I am Teacher Feli,
And I am Teacher Gracian.
and we are going to talk about subsets and supersets and anything in between. To start it off, let us talk about our lesson objectives. At the end of the lesson, the students must have identified subsets, power sets, and supersets, as well as defined the relationships between sets. Let's talk about firstly subsets. These are sets whose elements are all present in another set. In the given example, we have set A pertaining all of the pertaining all of the digits from 1 to 9 as its elements, and set B having digits 1, 2, 3, 7, and 8 as its elements. From this, we can create a visual representation of the similarities between the two sets. Mainly, that all of the elements of set B can be seen in set A. And we look at this, right? We have 1 for both, 2, 3, 7, and 8. That is why all of these elements can be found inside of set A and set B. Whereas the elements 4, 5, 6, and 9 cannot be found in set B, which is why they're only found in set A. And we can see that all of the elements of set B are present in set A. And all of the elements present in set A are also present in set A. Therefore, we can conclude that set B is a subset of set A, and set A is also another subset of set A. Now, with this confusion in mind, maybe some of you are wondering, how can a set itself be considered a subset of itself? Well, let's dive into the two kinds of subsets. You have proper and improper subsets. Proper subsets are subsets that have lesser number of elements than the original set, often denoted by this symbol, which is alike to your less than symbol. For example, you have the same given with set A encompassing elements of digits 1 through 9, set B having elements 1, 2, 3, 7, and 8. And here, as we have already seen, all elements of set B can be found in set A, and set B has a lesser amount of elements than set A. Therefore, we can conclude that set B is a proper subset of set A. Meanwhile, improper subsets are subsets that have an equal number of elements with the original set, often denoted by this sign, which is akin to your less than or equal to sign. For example, we have here the same given with A encompassing all digits from 1 to 9, and also set A and with the same amount of elements. Therefore, we can see that all of the elements of set A are within set A. However, they have equal number of elements. Therefore, we can say that although set A is a subset of set A, it is an improper subset. Another example that we have to look into is this. We are given three sets. Set A encompassing all even numbers from 2 to 20, and set B encompassing even numbers such as 2, 4, 6, 12, 14, and 18. And lastly, we have here set C having two elements, 2 and 12. From this, we are able to make this visual representation to make it easier for ourselves. As we can see, both the elements of set C can be found in set B and set A, right? 2 and 12 are all on three sets, and set C has the least number of elements. Therefore, we can say that set C is an element of is a subset rather of set B, and set C is also a subset of set A. making it a subset of two sets. And with this, we can also deduce that all of the elements of set B can be also found in set A, right? We have here 2, 4, 6, 12, 14, and 18, which means that since all of the elements present in set B are present in set A, therefore set B is a subset of set A. And lastly, set A in and of itself has the same elements of set A, which is again itself. Therefore, it is an improper subset of set A.
Next, we have power set. What is power set? Power set is a collection of subsets. It is often denoted by P and following the name of the set. For example, we have set A, which has the elements 1, 2, 3. And if we were to look at set A subsets, we have the following: subset 1, 2, 3, subset 1, 2, subset 1, 3, subset 2, 3, 1, 2, 3, and lastly, null subset. Therefore, if we were to combine all these together, and it is denoted by P, or power set of A is 1, 2, the elements or set 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, and null set or subset. So determine the power set of the following. The set A is all positive odd integers less than 10. Or if we were to translate it, set A has the values or elements 1, 3, 5, 7, and 9. And if we were to dissect its subsets, we have these subsets such as 1, 3, 5, 7, 9, 1, 3, 5, 7, 1, 3, 5, 9, and all the way to null subset. Therefore, the power set of A is the following: 1, 3, 5, 7, 9, 1, 3, 5, 7, 1, 3, 5, 9, 1, 3, 5, 1, 3, 7, 1, 3, 9, 1, 3, 1, 5, 1, 7, 1, 9, 1, 3, 5, 7, 9. And moving on to supersets. Supersets are parent sets of subsets that contain all its elements and may or may not contain additional elements. For instance, set A has the values 2, 4, 6, 8, 10, 12, and 14. On the other hand, set B has the elements 4, 6, and 12. And if we were to visualize it in a Venn diagram, we can see that set A has all the elements of set B, and set A has all the elements of set A. So therefore, we can conclude that set A is a superset of set B, and set A is a superset of set A. And there are two types of supersets. We have proper and improper supersets. So first, let us look into the proper subsets. These are supersets that have a greater number of elements than the original set, and it is often denoted by this symbol. For example, set A has the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and set B has the elements 1, 2, 3, 7, and 8. Therefore, set A is a proper subset, a superset rather, of set B. And for the improper superset, these are supersets that have an equal number of elements to the original set and is often denoted by this symbol. For example, set A has all the values ranging from or digits ranging from 1 to 9, and also set set A has the same values ranging from 1 to 9. Therefore, set A is an improper superset of set A. For example, set A has the elements 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Whereas set B has the elements 2, 4, 6, 12, 14, 18, and set C 2 and 12. If we were to visualize it using a Venn diagram, we can see that set A is has the has the values or has the values of set B and set C. And so set A is a proper superset of set B, and set A is a proper superset of set C. And we can also see that set B has all the elements present in set C. Therefore, set B is a proper set of superset of set C. And lastly, we can see that set A has all the elements present in set A. Therefore, set A is an improper superset of set A.
Now, let's talk about the relationship with sets. A relationship of set A to set B is a subset of indicated by A cross to B. Hence, our relationship consists of ordered pairs where AB, in which A or the first of the ordered pair is an element belonging to the first set, and B, the second of the ordered pairs, is an element belonging to the second set, and we can write this as a relationship of B. For a brief example, we have here A, set A, which has the following elements: A, B, and C, and set B having the following elements: D and E. For us to determine the relationship between both sets, we must first multiply each the first element of each of the first set to the elements of the second set, which is why we have A and B, A and E, B and D as a subset, and D and E, and so on and so forth, until we have no more from the set A, from the first set that we can multiply to the second set, which all of this gives us our subset of A cross to B, which is all of the crossing or relationship that we have identified earlier. In this much more complex example, we have set A encompassing all digits from 1 through 6, set B encompassing all digits from 1 through 4. However, there is a condition for us to say that an ordered pair is a relationship, which is they can only be a relationship if and only if the second value deducted by the first value when divided by 2 is equals to 0, which means that it should have no remainders. Now, first we must list down all of the ordered pairs, which is 1 through 1, until we reach the point that we no longer have anything to cross over from both sets, which is which now gives us the job to determine whether or not these ordered pairs, when deducted and divided by 2, is will leave us with no remainder. Now let's talk about the first one, right? Let's talk about the first one. 1 minus 1 is equals to 0. Divided by 2 is 0 and gives us no remainders, which means that it satisfies the condition. The second pair, on the other hand, 2 minus 1 is equals to 1. When divided by 2, gives us a remainder of 1. Therefore, it does not satisfy the condition, which means it is not a relationship. What on the 3 minus 1 is equals to 2. When divided by 2 is equals to 1 and gives us no remainder, which means that this can be considered a relationship. However, 4 minus 1 is 3, and when divided by 2 gives us the remainder of 1, and as such cannot give us a satisfied ordered pair, which means it has to go. And we have to continue this until we go over all of the following ordered pairs, which leaves us with this. And with all of these ordered pairs, we are able to create the relationship or the subset known as A cross to B, which is 1, 1 and 1, 1 and 3, 2 and 2, so on and so forth, until we reach 6 and 4, which all of these following ordered pairs satisfy the condition and thus can be considered part of the subset of the relationship. With all that said and done, I hope everybody learned from this lesson. Once again, I am Teacher Feli.
And I am teacher
Together,
Grishan.
yes. Thank you for watching today's episode. Bye bye.